Today we are going to talk about solving two-step equations. We've already learned how to solve one-step equations. Now we're going to take that one step further and solve two-step equations. Now our goal is the same as when we solved one-step equations. We still want to isolate the variable. We also start off the same way. We box the variable term and draw a line from the equal sign. Now, I will say that this time when we have two-step equations, this first step of boxing the variable term is more important than it was with one step. We are boxing that entire term that contains the variable. That will help us to determine which piece to do first. We will take a look at that in a moment, but I do need you to know that this step is required. We cannot skip over it. All right, after we've done the setup of the box and the equal sign, we ask ourselves again, how can I isolate the variable? I still use inverse operations. So the inverse of addition is subtraction, inverse of subtraction is addition, inverse of multiplication is division, and the inverse of division is multiplication. So I'm still using those same pieces that I used in my one step. We do continue to remember that whatever we do to one side, we do to the other side. We keep our equation balanced still, which is why we draw that line down from that equal sign. Our last step is to check our answer. It is, again, more important now. We've got more steps. You must substitute in your solution to check your work. So what we do with these two-step equations is we have a box around the term with the variable, which will give us a one-step equation, which is pretty cool. Okay, so let's go ahead and give one a try. We've got 3x plus 4 equals 25. So as our notes say, we put a box around the entire term that contains the variable. In this case, x is part of a term with 3. So our variable is x, and 3 is attached to it. That's the coefficient. So this is one term, so we box the entire term. And then I draw my line showing my balance. Now I keep these in a box and I ignore them for a moment. And I just see what's left on this side. Well, on this side, I have left a plus 4. So now I need to get this whole term by itself. How do I inverse plus 4? Well, the inverse of addition is subtraction. So I would subtract 4. Because I subtract 4 on this side, I will also subtract 4 on this side. Now I have bring down 25 minus 4, which is 21. And I can now unlock this box and bring down 3x, 3 times x. Now I solve another one-step equation and I see, okay, what's occurring here? 3 times x, 3 multiplied with x. Multiplication, the inverse of that is division. So I'll divide by 3. Because I divide by 3 on one side, I will divide by 3 on my second side. That x is now alone. And I take 21 divided by 3, which equals 7. Now, here's where you need to go back and plug that 7 in. My equation originally was 3x plus 4 equals 25. So now I need to take that 7 and substitute it in for x. So 3 times 7 plus 4 equals 25. Now I use my order of operations and go ahead and figure out what I've got. So to start with my order of operations, I have multiplication. So 3 times 7 is 21 bring down my plus 4. I'm still hoping it equals 25. And now I can simplify down. 21 plus 4 is 25. 25 equals 25. So yes, X is the correct solution for this equation. So to recap, I boxed the entire term that contains the variable and drew my line. Then I solved, I got that 3x that was locked away, and I tried to get that entire term by itself. I did that by subtracting 4 on both sides. I got my 3x now, but I need to separate the 3 and the x. I do that by dividing on both sides, leaving me with my solution, which I substitute in to check my work. We're going to do one more together. Here we have x divided by 5 minus 7 equals negative 4. So again, I boxed the entire term that is attached to that variable. So that divided by 5 has to stay attached to that x to start. Now I draw my line. Okay, so I want to get this x divided by 5 by itself. Here I have minus 7. So how do I inverse minus 7? Well, the inverse of subtraction is addition. So I add 7 to both sides. Those cancel, and I can bring down my x divided by 5 now. Now, we've got integer negative 4 plus 7. I know that negative 4 negatives and 7 positives will leave me with 3 positives. So now I have the one-step equation, x divided by 5 equals 3. So I ask myself again, how can I isolate this variable? Well, it's being divided by 5, so to inverse that, I'm going to multiply by 5. 5 times 5 divided by 5 cancel out, leaving me with an x by itself. Now I have 3 times 5, giving me a solution of 15. But I'm not done yet. I need to now take that x equals 15 and substitute it in. I take that 15 and plug it in. Okay, so what do I do first to solve this? Well, using my order of operations, I would divide first. 15 divided by 5 is 3. Bring down everything else. Now I have integer subtraction, so I keep my first number, change my addition sign to, my subtraction sign to addition, and find the opposite of my second number, hoping it's negative 4 still. 3 plus 7 negatives does in fact get me, negative 4. So my solution is correct.